Now we get to look at the normal distribution. This distribution is incredibly important for the inference that we're going to do for the rest of this course. So we want to make sure that we understand how to calculate probabilities from a normally distributed random variable. The normal distribution has a few really special properties. One is that it's symmetric around its mean. Another is that the turning point, so the curvature, where it turns from curving downward to curving upward, always occurs exactly one standard deviation away from the mean. And we see that the mean and the standard deviation define what these normal distributions look like. So on the left, you see three different normal distributions. One centered around 10 with a standard deviation of 5. Then when the standard deviation goes to 2.5 in that second curve, we end up with a smaller or a narrower curve, but it ends up being taller because we still have to have an area of 1. And if we can't have a wide graph, we have to have a tall graph. And then the third one has a higher mean, so it's centered at 70, and it has a larger standard deviation, so you can see where it's spread out more. So for any normal distribution, you need to know the mean and the standard deviation, and then you'll be able to know exactly what this curve looks like. We're going to start by looking at the standard normal distribution that has a mean of 0 and a standard deviation of 1. This is that standard normal curve that's sometimes called a z-curve. We're going to be looking at table 2 in order to find these areas. It requires calculus for you to be able to do these areas with the function, but the tables have all the values already worked out for values between -3.9 and +3.9, where it's counted by hundreds. So it has a lot of values in there. And then we'll also learn how to do this in StatCrunch so that you can do it a lot quicker without having to use the table, but you're going to have an option of which one you'd rather choose. We are going to be looking at 3 different types of probabilities, and the table is going to give you the probability that your z variable is less than some particular value. So if you're looking for area to the left or a probability that you are less than a particular number, then that's exactly what's going to be given in the table. If you're looking for a greater than, then that's not what's in the table. You have to do 1 minus the value that is in the table. And then when you're finding between, you can find that by subtracting the big area, where z is less than the bigger number, minus the probability that z is less than the smaller number. That's going to leave you with the piece that you want, much like the triangle example that we did in section 6.3. Let's start with some basic calculations using the table. We want the probability that z is less than -1.76. So the table is organized where the column on the left gives you the ones digit and then the tenths digit. And then each row or each column after that is giving you the hundredths digit. So -1.76, you'll start at the -1.7 row, and then you go to the 0.6 column, and your answer is 0.0392. And that's it. If you wanted the probability that z was less than or equal to 0.58, we need to go to the positive table, which is just the second page, and we go to 0.5, which is that row, and then we go to the 8 column, and so we get the answer 0.7190. The third part, z is less than -4.12, you'll notice that the last value that we have is -3.89. Anything smaller than that is going to be even smaller than this last entry. And since the last entry is 0, then the probability that you're even smaller than that is going to also be approximately 0. Now let's look at a greater than problem. The probability that z is greater than -1.28 is equal to 1 minus the probability that z is less than -1.28. We have to switch to that because the table gives us the probabilities to the left, or the less than probabilities. So we find negative 1.2 for the row, and then we go to the 0.8 column, and we get this value 0.1003. So we'll do 1 minus 0.1003, and our answer here is 0.8997. The between questions, and you can't read that, I'm sorry. The between questions, you're going to do the larger value, you'll subtract the smaller value. Notice here that we are going to have to look up in the table two different values. So the subtraction does not come with the original values. You have to get values in the table and then subtract. So first we get the probability that z is less than 0.58. So it's going to be on the positive table, and we go to 0.5, and then we go over to 8, and we have 0.7190. And then we go to the negative table for negative 1.76, and actually we've already done that one. It's 0.0392. And so we'll subtract those two probabilities to get the answer. One thing that students do often on these is they subtract first, and then their answers end up being really weird. It's you get the two probabilities from the table and then subtract that. All right, now for F, we're looking for the probability that z is greater than 1.96. So we go to the positive table, and 1.96 is right there, and we get 0.9750. But since this was a greater than problem, our answer is actually 1 minus that value. And so our probability answer is 0.025. And then the last one here, the probability that z is between -2 and 2. So what this value actually represents is the probability that we're going to be within 2 standard deviations of the mean. So if you remember the empirical rule from 2 weeks ago or so, the empirical rule told us that the probability that your observations will be between 2 standard deviations of the mean is about 95%. So let's see what we get when we do these calculations. So we do the larger value, then the probability of the smaller value. So 2.00 is 0.9772. And then we subtract the probability for the -2. So negative 2.00 is 0.0228. And then we'll subtract those probabilities, and we see that it's 0.9544, which is 95%, like we saw in the empirical rule.